Hi, welcome to the channel. I'm Mrs. R. Let's do some math. Welcome. We are talking about distance, rate, and time problems. Now, these are problems that combine the idea of distance, rate, and time, but it's not just a pure use that D equals RT formula. We're going to be combining some things, making some calculations. So here's a very common type of distance, rate, time problem. We have an aircraft carrier making a trip to Guam and back. The trip there took 3 hours, and the trip back took 4 hours. And this aircraft carrier averaged 6 kilometers per hour on the return trip. Find the average speed of the trip there. So where this idea of distance, rate, time comes into play is that those three things are related to each other in a very specific way, where distance equals rate times time. So however fast you're going, for however long you're going, that's your distance. Where this gets a little more confusing than just, well, how far did we go, is because we're talking about two different trips. We have a little bit of information. We have information about one of the trips. We want to know information about the other trips. Let's look at the trip there first. The trip there took 3 hours. We know our t equals 3. And we want to find the average speed of the trip there. That's the rate. We don't know that yet. Then if we look at the trip back, it says that took 4 hours. So our time is 4. And we do know our rate. Our rate was 6 kilometers per hour. So when we look at our distance equaling rate times time, 6 times 4. Now, we could solve that and we know the distance is 24. We don't actually need to know that the distance is 24 though, because this aircraft carrier is making the trip to the island. I don't actually know what the island of Guam looks like. And then it's making the trip back, right? That distance is exactly the same. It's all the same distance. So a lot of times what your easiest path is going to be in these problems, because you're talking about two different things, but they are linked together with some common information, is to actually set these two trips or these two drivers or these two people or whatever it is, and have kind of each of their equations, but set them equal to each other, like have an expression for each of them. So with our distance being rate times time, right? Over on our there side, distance would be r, our curious, we don't know what this is yet, times 3. But since those d's are the exact same distance, we can say that that r times 3 equals the 6 times 4. Now, if you had already looked at this and said, well, I know 6 times 4 is 24, then maybe you just wrote 24 there, and that's fine. But sometimes we'll have not as straightforward with numbers. Sometimes there'll be expressions on both sides that we can't simplify yet until we put them together. But since those d's, the distances were the same, and we had expressions for the distances, we can set them equal to each other. And now 3r equals 24 if we kind of simplify and put this in the notation we're used to. And then it's just a one-step equation divided by 3. So then our r that we're looking for is 8. Now we are finding average speed. So to put this back in context, we were talking about kilometers per hour. So that would be our answer. Now we're going to look at a little more complicated one, but we're going to use the same kind of idea on analyzing the problem and seeing how we can put it together. Here we have one of the classic algebra train problems that everyone loves to make fun of. But we have a cattle train leaving Miami traveling towards New York. 14 hours later, a diesel train left traveling at 45 kilometers per hour in an effort to catch up to the cattle train. After traveling for 4 hours, the diesel train finally caught up. What was the cattle train's average speed? One of the things to realize here, so this is on our distance, rate, time section, so we are working with that idea of distance equals rate times time, right? The other thing to think about is that when the train catches up, at that point, the distance is equal. So this is a lot like the problem that we had before, where we had kind of an expression for the trip there, an expression for the trip back, but the distance was equal, so we could have them equal to each other. We can do the same thing here. So we can have an expression for the cattle train, how fast they're going, how long they've been going, and we can have one for the diesel train. So when we think about the time, after traveling for 4 hours, the diesel train finally caught up. So it leaves, it's been traveling for 4 hours, so the T is 4 for the diesel train. And they give us the speed for that one. So the rate is 45. Now the cattle train we have to think a little more about. Obviously, if they're asking us what was the cattle train's average speed, our rate is, we don't know. We can just put an X or a question mark, or we'll leave it R or something. We don't know how fast the cattle train's going. But when we think about the time, think about everything that's in this question. So the cattle train left and traveled towards New York. 14 hours later, a diesel train left. So we had 14 hours before the diesel train even left the station in Miami. After 4 more hours, after the diesel train had been going for 4 hours, then that's when he finally caught up. So our time the cattle train has been going is 18 hours. Our rate times time over here is an 18 times R. So that's our distance. D equals 18R. But that's the same distance as over here with our 4 or 45 times 4. We have 18R equals 45 times 4. So we'll simplify that a little bit. 18R equals, if you need a calculator for this, that's a thing. But I know that 45 times 2 is 90. So then times 2 again to make the 4 would be 180. And now it's just a one-step equation. So we need to get that R isolated. So we'll divide by 18 to cancel the 18s to 1. Divide by 18 there. So then R equals 10. Now back into context, this rate is an average speed. We were talking about kilometers per hour with the other speed, so this would be kilometers per hour also. So the cattle train was going 10 kilometers per hour. And that's why even after having a 14-hour head start, the diesel train only took 4 hours to catch up. That's the idea with these distance, rate, time problems. Remember, the main idea you're working with is the fact that distance does equal rate multiplied by time. But in these story problems that you tend to get, there's kind of 2 different scenarios, but they have something in common. Either they're going the same speed and you have to find distance, or they're driving for the same amount of time and you have to find something else. The 2 examples we did, they were both related to the distance being the same. And depending on where you are in your Algebra 1 journey or Algebra 2 journey, this is kind of an Algebra 1 level. Same idea would apply for an Algebra 2 distance, rate, time problem, but it may get a little more complicated. So this would be your basics and you'd have to build up from there. But the idea, you've got your 2 different expressions, set them equal to each other as appropriate, and you can find your answer. So thank you for joining me for distance, rate, time problems. If this video was helpful for you, please hit that like button because that helps us make more videos. And if you still have questions, leave a comment. If you have other concepts you want to see videos for, leave a comment. But ultimately, I'm Mrs. R, and this was me doing math. See you next time.